Hey guys, it's me again, Captain Corey, here to teach you all some sixth grade science. Last time we were together, we introduced the topic of the role thermal energy has in phase changes. We watched 3 different videos together. One was showing the Mpemba effect, and that showed us that hot water freezes faster than cold water. Who would have thought? The next video, we got to see bubbles freeze in slow motion. That was neat because you could actually see the movement of the bubbles slow down as it got colder. Since today is explained, we're going to dive deeper into the role that thermal energy has on phase changes. Now, thermal energy is energy that is generated and measured by heat. An example of thermal energy is the kinetic energy of an atom. Kinetic energy is energy of motion, and atoms make up all of matter. So I want you to pretend that you are a water molecule. Yep, stand up and be a water molecule and be proud because water is super important. You are now officially made up of 2 hydrogen atoms and 1 oxygen atom. Now I want you to pretend to be water in its solid form. You should be slightly shivering for 2 reasons. One, because you are ice and it is below 0 degrees Celsius. And another reason is because water molecules in solid form are constantly vibrating. Now stop vibrating and become a liquid. You are now fluid and can move all around. You can slide past other water molecules and your thermal energy has increased. Notice that you can move faster because you're not so close to the other water molecules. Now, if we turn up the heat some more, you will eventually turn into a gas. At this point, you should be running all around the room at top speed. Okay, you can pause now. But you should be able to physically feel that once the phase changes from a solid to a liquid to a gas, that the temperature increases also. Now in reverse, from a gas to a liquid to a solid, the molecules slow down and the temperature lowers. We are going to go to the notes, effect of thermal energy in the Google Slides and fill out the notes in your science journal. I will go through these notes with you and you can fill out the ones on your personal copy. All right, so here are the notes. If you look in your science journal, they should look like this, and we're going to copy everything that is in yellow. All right, thermal energy and phase changes. This is the brain pop video that we watched on day 1. If you want to rewatch it, you can feel free to sign right in. All right, physical states of matter. So the removal and addition of heat causes materials to change states. Like if we have liquid water, when we add heat to it, it evaporates and turns into its gaseous state. But if we have liquid water and we remove heat from it and like place it in the freezer, then it will become a solid and it will change to that state. So when thermal energy is subtracted, that means that the temperature is lowering. All right, so if a volcano erupts and liquid magma is everywhere, as it cools down, it becomes solid rock. And liquid water, when it gets really cold, it turns into solid ice. And as you can see, here's our liquid magma turning into a rock and our water turning into solid ice. So now let's think about it, okay? When thermal energy, which is heat, is subtracted from liquid water, what does it become? If you said ice, you were right, all right? So as liquid water cools down and gets below 0 degrees Celsius, it turns into ice. Now as thermal energy is added, that means we're turning up the heat and it's getting hotter. That's when we start seeing our solids turn into liquids, right? And our liquids turning into gases. So as the temperature increases, it gets hotter, molecules are moving faster and faster and moving farther and farther and farther apart. So another question. When thermal energy is added to liquid water, then what does that become? Water vapor, right? Gas. If you said that and you guessed it before we switched, you were right. All right, so as you can see in this diagram, when we add thermal energy, it goes from ice, right? It melts into liquid. So we have solid ice melt into liquid water, and then it evaporated and turned into a gas. Now, as we are subtracting thermal energy, which means that it's getting colder, then we have our gas is going to condense and turn into a liquid. And then we'll have our liquid freeze and become a solid. So the addition and subtraction of thermal energy causes phase changes. So the phase isn't going to change if no thermal energy is added to it or subtracted from it. So as thermal energy is added, like we said before, molecules speed up and they're further apart. And as thermal energy is subtracted, which means it cools down, then the molecules slow down and they become closer. And here is a little example of molecules together at a solid. See how they're closer. We see at a liquid how they can move more, and then at a gas they're moving the fastest, and how the temperature increased with each one. So now today we have an at-home experiment for you to try. These are the materials that you will need. You will need 2 plastic cups or an ice tray, tap water, freezer, and a timer. So all you're gonna do is you're gonna fill up 1 cup halfway up with hot water and 1 cup halfway up with cold water. Now, if you're using an ice tray, just fill up half of the trays with hot water and the other half with cold water. Now, this is tap water, okay? And you're going to place both of them in the freezer, or the one tray in the freezer, and you're going to predict which one will freeze first. Now, if you were listening to the notes and you've seen the videos, you probably already know what's going to happen. Now you're going to check every 20 minutes and collect data to see which one of them freezes the fastest. And then tomorrow, we're going to have a PhET demo. Now, I'm going to show you how you can access this. There's a worksheet in your science journal. I'm going to share my screen so that you will be able to see what that will look like. All right, if you download it as a Microsoft Word, then it will look like this. And you'll be able to have the link right here that you'll be able to click right on. If you are using it as a Google Doc, then the link will be right here. What I suggest you do is to click that link and have that part already up in your tabs. And you'll click on states, right? Now to do it with the Nearpod, you'll go to nearpod.com. Wait for it to load. You'll go to join a lesson in the student section. You'll put in the code GCMLS. Bam. Then you'll put in, I'm gonna make it full screen. Put in your name and join session. And then here it goes. So here is where you will, it gives you instructions. And then it has the page, but you don't need to click this page because you already have the web page open right here. So then you'll click over here. And then you'll go to the next page. So it says click on the states. We've already done that, and let's get started. So the first thing it tells you to do is change the temperature to Celsius. I'm gonna move myself to this side. You go over here, and where it comes down, you'll change the temperature to Celsius. Bam, number 1, done. Click back over to your Nearpod and go to the next slide. Then it says draw neon as a solid and write the current temperature beside it. So if we go down here, we can look and we see that we're already on neon. Click solid, it's already on a solid, and then you'll write down that temperature. So you come over here, you can pick whatever you want. You can make it the same color if you want, and you can draw neon. And they even have where you can type, you can put what temperature it is, right? So you draw it with the temperature and you can submit it. Now, I expect you to actually draw it out. This is just for demonstration purposes only. And then the next, it says click on water. So you'll come over here and you'll click on water and you'll see what water looks like. And it says draw water in a solid form and write the current temperature beside it. So you'll come over here, look at what water looks like. We know that it's a solid, and then you'll include this temperature. And you'll go so on, and it'll tell you to do different things, and you'll be able to draw it in there and answer different questions that they have for you, and it gives you each step. So you have two options on how you can go through and do the PhET demo. You can either just write it down. I mean, you can print it out, write it down, or do it on the computer, or you can do it with the Nearpod and submit it. Either way you do it, it's fine. Whichever one works for you is the one that you should choose. So until next time, it's been Science with Captain Corey.